So I'm going to do an example that I actually haven't written on the slide presentation. This is going to be a completely different example. It's going to be slightly more difficult than anything that's on the slide presentation, and that's why I think that it will be valuable for you to see how I do it. So let's say that we start out with a rational expression that looks like this. I've got x squared plus 6x minus 16 over x squared plus 3x minus 10. Okay, so if we're going to follow the steps that I have outlined for you, what I need to do is I need to factor the top. Okay, then I need to go ahead and I need to factor the bottom. Ooh, lightning yellow. Kapow! Alright, so let's start with the top. The top, x squared plus 6x minus 16. What do we know about this? This factors into two binomials. And since there's no leading coefficient, that doesn't mean that there is no leading coefficient. It just means that the leading coefficient is 1, which means that both of these suckers here have a leading coefficient of 1. Now, this is minus. And the only way to get a negative is if you multiply a negative times a positive. So we know that one of these is a plus and the other is a minus. And we're looking for two things. We're looking for two things that multiply to give us negative 16, okay, and add to give us positive 6, okay? Add to give us positive 6, multiply to give us negative 16. Okay, so let's try and figure that out. 16 is 1 times 16. Okay, so 16 minus 1 would be 15. That doesn't work. 2 times 8, let's see. 8 minus 2 would be 6. So actually, we already know what this is. Okay, we know that this is x plus 8 times x minus 2. How do we know that? Because negative 2 times 8 is negative 16. Negative 2 plus 8 is positive 6. Okay? Wonderful, wonderful, wonderful. Let's go ahead and also factor out our x squared plus 3x minus 10. Again, we open and close our two parentheses, and because our leading coefficient is 1, we put just x there. And because this is a negative and this is a positive, we're going to put a plus and a minus. And again, we're looking for two numbers that multiply to give us this end thing and add to give us that right there. Okay, so we've got 1 and 10. Okay, 10 minus 1 is 9. That's not going to work. 2 and 5. Oh, look at that. Once again, 5 minus 2 is 3. So we're in business. So we know that the bigger number is going to be the positive number. X plus 5 times x minus 2. 5 times negative 2 is negative 10. 5 plus negative 2, or 5 minus 2, is 3. So we're good. So that means that this rational expression over here factors into x plus 8 times x minus 2 on the top, and then x plus 5 times x minus 2 on the bottom. Well, I see something that I'm multiplying. It's a factor that's common to both the top and the bottom. Does anybody else see it? Yes, I know you do. Yes, yes, you. I'm looking at you. That's right. The x minus 2 cancels out because that is the common factor. You can get rid of it because it's the same on the top and on the bottom. Remember, this does not work with addition and subtraction. The rules for addition and subtraction are always different from your rules for multiplication and division. Since these things are being multiplied, we get to use our rule for multiplication, which means that these things, x minus 2 over x minus 2, equals 1, because you have the same thing on the top and the bottom, therefore they cancel out. So our answer to this is x plus 8 over x plus 5. And you have put that rational expression in its simplest form.